Dear ladies and gentlemen, my name is Markus Eider. I'm a research assistant at Deggendorf Institute of Technology, and I present you the topic Requirements for Prescriptive Recommender Systems Extending the Lifetime of EV Batteries. The lithium-ion batteries in electric vehicles nowadays degrade over time, and this is a permanent and inevitable process which is highly dynamic and also based on the usage of the EV. This means that EV users can influence how fast the batteries in an electric vehicle can degrade. And this is why they require knowledge on the battery-friendly EV usage. To give you some background, there are some exemplary battery degradation causes on this page, such as extreme temperature. Both negative or high degrees Celsius temperatures are harmful for the battery health, such as above 30 degrees Celsius. And in this regard, there's the main problem. Especially users that are new to electric mobility mostly do not know how to use an EV battery friendly. One could use instruction and training for those users, but this doesn't cover the dynamic context in the real world. Different degradation causes can appear at the same time, and so on. So users require recommendations or advice, which is context-based and prescriptive, meaning that those recommendations fit the current trip and the upcoming usage. So we define the research question, which requirements do prescriptive recommender systems have, in short PRS, that provide users with battery-friendly EV usage advice? In order to answer this question, we define the methodology as follows. First, we identify existing decision support systems from literature and determine which common requirements exist for them. These requirements will be collected in a list of functional and non-functional requirements, and we determine if some recommendations are optional based on the application case of a PRS. And in the third step, we evaluate the requirements in a simple use case regarding their suitability for our case and also the practicability for implementation. But first, I want to provide a short background why we use the term prescriptive. There's a data-driven approach from maintenance which uses three classes. First, we have descriptive maintenance, which describes the current and past system health state, and therefore usually we use sensors to acquire data and analyze this data in a manual fashion. Nowadays, there's the term predictive maintenance, which enhances this descriptive maintenance by forecasting the system state in the future. Usually we apply machine learning techniques such as neural networks or support vector machines. And above this, there is the so-called prescriptive maintenance, and this then provides recommendations for the future. Since predictive maintenance only tells us how the system state will be, but does not tell us what we should do. And here, usually artificial intelligence is also included. Hence, as we want to provide recommendations to EV users, we have the term prescriptive recommender systems. In order to determine the requirements for PRS, we take a straightforward approach. First, we identify research papers on decision support systems, then analyze their texts. Just in this example from Sultanpur and Celis, there's the following sentence. I marked the important part with yellow color. First, we have the statement acquire data from different sources, then the block process them to elicit meaningful patterns and insights, and distribute the results to proper stakeholders. All those statements can be formed into requirements, but we need to be aware which statements are to be ordered to functional and non-functional requirements. Now I can propose a list of the first functional requirements that we identified, and these are grouped by colors. First, we have the requirements for the inputs of the PRS regarding the data that needs to be analyzed, such as EV data. Then we have the processing requirements, which tell how the internals of the PRS should work. And we have the outputs, which tell how the recommendations should be provided, and so forth. There's also the column optional, abbreviated by opt, which tell if a recommendation is not essential. Such, if we take a look at the last requirement, number 19, execute recommendations, this is not always the case because in our case the PRS cannot control the electric vehicle, so this requirement is optional. Also, we have 10 non-functional requirements. The first 3 are usually known from software engineering, such as a system needs to be scalable. We kept the requirement number 10 optional because we think it's the designer's choice if the users of the PRS should be educated by the recommendations. Now that we know our requirements, we can evaluate them in a very simple use case. We take the fact that lithium-ion battery degradation accelerates above 20 degrees Celsius temperature, and also under the constraint that the battery pack itself is not thermally insulated from the environment, meaning that if we drive during a summer day, the batteries can get hot. And then we can provide the recommendation, after the end of a trip, please park your electric vehicle in a garage, so that the cells can cool down. Now we have our list of requirements, now with 2 new columns. The highlighted one is if the requirement applies in this use case. Also, we have a comment, a discussion of every requirement in the paper. I don't want to go into detail here. However, it's important that some requirements do not apply, such as requirement number 9, that the PRS needs to comprise state-of-the-art AI techniques. In this use case, our decision is so simple that we can solve it using Boolean logic. So requirement number 9 is not necessary. And now the rest of functional requirements we see in requirement number 19. As discussed before, executing recommendations does not apply here because the user stands in between PRS and EV, so the PRS cannot execute the recommendations. And here we have the non-functional requirements. The discussion of these can be found in the paper again. However, the most important facts are that requirements number 8 and 10 are excluded. The reason for this is with number 8, providing a reasonable amount of recommendations does not apply because we only have one recommendation in the use case. Also, the education in number 10 is not necessary and doesn't apply because it's not defined in the use case. Also, the requirement is optional. If we think of implementing a PRS, we have to take into account a few important points. For example, we need to be aware that various data sources are necessary. When thinking of electric vehicle battery degradation, we probably need electric vehicle CAN bus data and web-based APIs in order to receive usage data of the EV. Spatial data and weather forecasts may also be helpful. This allows us to accurately determine the operation state. Also, state-of-the-art technologies should be sufficient for implementation. In the use case, as we had before, a simple rule-based decision support system can determine the necessity of a recommendation. However, we might need machine learning or artificial intelligence for complex cases. And also, not to forget, we need to think about data privacy and security. There need to be contracts with the user, and his consent should be received before operating this system. Also, we need to make sure to use dedicated security mechanisms and to handle personal data properly. I hope this presentation was interesting for you, and if you have questions, please feel free to ask. After this session, you can also contact me via email or telephone. Thank you very much for your attention.